In our demo, we brought a few different vulnerabilities together to show us how excess model agency can be problematic. We had a poisoned model, didn't perform any validation on the output, and didn't apply the principle of least privilege. It had permissions to access far more than it needed. If we're not careful, then all these things could come together to cause serious problems. So what does a good defense look like? The very first defense should be threat modeling. We've touched on this before. Hopefully, early in the design phase, we can make time to think about the threats we face and whether we're happy to accept the risks that come from them. If risks are significant, we might want to reconsider our design. In our demo, that really was a bad design. Giving the LLM the ability to fully control functionality is a bad idea unless we've got significant other security to protect us. While we should always perform input validation on data from a user, we can also have input validation on data coming from the LLM and going into other tools. Each tool should validate its own input. Validation is always relevant to how data is being used, so if we expect the LLM to give us JSON, then not only can we validate that it is JSON, we also validate it against a schema. That's good security, whether the data is from the LLM or not. More context-specific defenses are important too. If a tool sends data to a database, then we want SQL injection protections. We should have things like parameterization to help the database understand the separation between data and commands. There are Pluralsight labs and courses on SQL injection if you want to know more. There should also be least privilege. Your database user is very unlikely to need full administrative access to the database. It likely only needs to read from tables and maybe write to some of them. These concepts work in any context. Back to the command line example. That'll run as a specific user on the operating system. That user could be limited to only access certain directories and have no other permissions beyond that. You can also apply parameterization to command line requests to help stop command injection attacks. We need to know the tools we're passing control to, the weaknesses they suffer from, and the protections to apply. You might even consider having a human in the loop, a real person validating output before critical actions. Driverless cars, for example, often have a human in the loop. An evaluation LLM is an option too. We've mentioned this before as an extra layer of protection, using other LLMs to check either input and/or output from the primary LLM. So if a model can access a database, an evaluation prompt might be assess the entered text for SQL injection risks or attempts to perform anything malicious against the database. If it looks malicious, then state true, otherwise state false. Or if you really did need to call the command line, then something along the lines of assess the entered text for malicious commands that target the Linux operating system or breach confidentiality. Users can access data from the folder /user data, but no other directories. If it looks malicious, then state true, otherwise state false. The more specific you can be there, the better. But as we've mentioned throughout this course, you can't ever completely trust the output. So, using another LLM to evaluate data should only ever form part of your defense. More layers are required. Ideally, we want as many of these layers as possible. Placing all our trust in a single layer of security is a bad idea. There's a security principle called defense in depth, which tells us exactly this. Code that relies on multiple defenses is typically robust from a security perspective.